Hi, this is James Governor. I'm the co-founder of RedMonk, and I'm lucky to today have a great guest, Eric Fourrier, the CTO of GitGuardian. We're here to talk about LLMs in secrets detection. Now, I know there's been a lot of hype about LLMs, but here we are, 2024, so we've had a year of what to do with it, 2023, and now we're seeing some execution. So yeah, I'm keen to have this conversation. Eric, welcome.
Yeah, great to be here and talk about it, James. I look forward to it.
So I had a discussion with you beforehand, obviously a little bit of preparation, and I think there's some interesting things here because there's been so much hype around the use of LLMs, and I think for a software company, hype aside, it certainly creates some interesting challenges, some of them possibly even existential. I think one of the real questions for me is, or in fact, we've got two things. First of all, why don't you say a bit about GitGuardian, what it is you do? Secrets detection, why is that important? Who are you as a company? What are your bona fides?
Yeah, so great question. So GitGuardian is a code security company specialized in, we're really known for detecting secrets in code. We are the actually most installed security application on the GitHub marketplace with more than 300,000 installs. So it's used by individual developers, small companies, mid-market companies, large companies all around the world. Definitely with, I will say, the past 10 years with the DevOps and microservice revolution, the number of interconnected applications has grown so much. And you need definitely what we call like secrets. So it can be database credential, API keys, tokens so machines can talk together. And we have assisted the past 10 to 15 years to what we call the secrets sprawl. So this idea of the secret spreading everywhere in your infrastructure and especially in code. And GitGuardian specializes in detecting, helping developers to not only like find the secrets in code, but help companies really try to do the remediation at scale, meaning like putting secrets out of code.
Okay, because obviously we live in an era where software gets shared a lot, and it certainly gets cut and pasted, and secrets will find their way into production code, unfortunately, unless you have a decent solution to that. Okay, so that's a good backgrounder. So let's talk a bit about LLMs. When this technology emerged, obviously as a company, you've got to think about, well, what are the implications for us? So what was your journey, and what have you learned about the implications of LLMs in code security as an application?
Yeah, so it's a great question. I think as every software company, 2023 has definitely marked like the explosion of generative AI. And every company has seen and looked at the different application and implication for its own business, and cybersecurity is not an exception. And as a company, as a software company, you have to actually see like this new technology and benchmark them and test them to see like if they can improve your own piece of technology and improve the product for the customers. And that's actually what we did at the first, as a code security and secret detection company, especially GPT when GPT-4, even the 3.5 was released. Like the first question we asked ourselves was like, can GPT-4 like with a good prompt outperform the secrets detection algorithm we just built the past 5 years? And that was actually, I think, and a lot of companies, when you think about it, should do the same, should ask the same questions and do the same testing about their own.
It is a scary one. Does this put us out of a job? That's an existential question, as I say.
Exactly, an existential question. So, and we are, we come from. I'm an engineer myself. We have a strong engineering background, so it's just what we do. Try to find the best solution for the right problem. And so we did basically this testing of how really trying in a really scientific way to compare really ChatGPT against our own secret detection module, and really with exactly the type of problem we're trying to solve. So we are scanning the full real time GitHub pipeline. We're scanning everything in real time. So just to give some order of magnitudes, we scan around like 10 million documents per day on the public GitHub pipeline. So it's an average of like 100 documents per second. So if you do a small math and small approximation, the document is like 500 tokens. It gives you like around like because the pricing of a GPT is based on the token. It's a token price.
Yeah.
It's around 3 million tokens per minute that you have to scan. And so we need the first like step we want to see is like, okay, what's going to be the cost of because at the end of the day you have to pay a certain price for GPT. So the main three, I would say, component of the benchmark are like, if we have to replace and use it as a technology, we have to quantify three stuff. Is it like,
you don't want it to cost more than the GDP of France?
Exactly. Is it expensive? Is it fast? Is it performing well? Meaning, like for our use case, and even for any code security use case, when we think about performance, not only when I'm not talking about the speed of the algorithm, I'm talking really about what we call the recall and the precision. It's really this ability for us to, the recall is the ability to not miss any secrets, and the precision is like try to quantify like the amount of false positives. So it's usually the classic trade-off of a detection algorithm, like not missing anything, but at the same time not raising too many false positives. So on the cost, I think that for us it was a big realization that was pretty easy to calculate. Is like with GPT-4 for us, the cost will be 200K per day, which was definitely impossible to maintain compared to our current architecture, which is maybe a couple of $100 per day. So definitely on the cost side, it was definitely not doable. So you had alternatives. You could use like GPT 3.5 in Turbo, which was less performant, but also less costly. So for example, for GPT 3.5 Turbo, the cost is way less than GPT-4, and it can go to 4 to 5K a day. So the first issue was the cost. The second one was the speed. Is like these like LLMs are a huge model, and even everybody knows, and it's a big strength of OpenAI company, and I will say a company building large language model is the training. The training part of the model is insanely long and costly, and you need tons of GPUs to do it. And you can see right now a lot of in the news, especially with Sam Altman and other people looking to buy and even to build their own hardware to be able to train even more larger model. But people also,
I think on valuations now, NVIDIA is beginning to look like a cloud hyperscaler. The value, certainly at the moment, yes. GPU market's gone mad.
It's insane. I think what's really interesting is one of the first time, like if you look at, I think there is this trend in the market where NVIDIA valuation will be higher than Google. So for the first time in history, a hardware company, the valuation of a hardware company will be higher than a software company, which is, when you think about it, is really amazing for compared to what happened in the last 20 years. So the second step we're mentioning is the inference is still like, well, we're still talking about huge model with billions of parameters. So like the inference time is pretty long, especially for a large file or a large document. Usually the inference time is linear with the number of tokens. So the speed was not, hopefully our model was like more was faster, cheaper, and also after the last step for us was checking the performance. So like even if we had infinite money and infinite time, would GPT-4 perform better than our actual secret detection? And we realized, so on the benchmark, our model was still beating GPT-4, even if the performance was not bad, to be honest, but our model was still beating it. The stuff that's and sometimes a lot of, I think, people forget about the LLM is like by design, and in their own design, they are non-deterministic and it's stochastic model. If you run them multiple times on the same input, the output can be different. And it's a tough one for any detection problem in the security space, because as a company, for your customers, you usually perform like regular scans and periodic scans, and you don't want like that two different scans of the same input data, so of the same code at two different points in time, will actually output different results for that.
Yeah, no, that's not ideal when you're trying to manage security.
So definitely, so it's a huge stuff that's really important, I think, to consider, and that's outside. I will say the fact a lot of people talk about hallucination, but people forget the fact that there is also the stochastic part of the models that need to be taken care of. So that was, I say, our first realization, but so really interesting for us, and I think it's super interesting to see that for us, like and don't take me don't get me wrong. I think the LLM and AI is a game changer for our business, secret detection and code security in general. But it's not on I think, the most added value, and it has also added value on the detection. It can help on some stuff, but we deeply believe for us from a technological standpoint that on detection it will always be hybrid model with a first part that's really fast, deterministic, and that's perform really well, and really having the LLM models on top of it, for example, to solve different other use case, which could be filtering false positives, and also the big advantage we see for the big use case we see, and that's, I think, true also for code security in general, not only for secret detection, is on contextualization and helping people to look at the context around the code, around the secret, the different application, and be able to to provide like some tags, some context, so the security user or the developers can use it to better understand the issue and take and better do the remediation. So,
but by the way, I thought we'll talk about the remediation in a second, but I thought the prompt itself that you were using was interesting, because it's worth talking a bit about that, because the first line of the prompt, and we'll share the prompt in the video, but I think it's a classic, an absolutely classic first line of a prompt. So I don't know.
So the first line of a prompt, as you say, it was just like giving really the outline and the context to GPT to do its work. Was like, you are an expert in secret detection in source code, and you will receive code snippet, and your role is to detect secrets in code. So really, we try to we benchmark multiple prompts, and so that was usually the first
You always have to tell it it's an expert, right? That's the thing that I love about ChatGPT. It's like, this is the way you need to think about it. You're an expert in this. Don't commit it like an amateur.
So I think the prompt has a huge in any way, the prompt has always a huge influence on the quality of the result, and having a good prompt is definitely a key to have great results, and that's what we talk about right now in the industry, about prompt engineering. And I think you have even now job titles about prompt engineers. So definitely an area to master in the LLM and AI world, I would say.
Absolutely. So to talk a bit then, as you said, about remediation. That's one of the areas where, So it turns out that whilst code gen may be part of the problem, it's also part of the solution. So for remediation, you see that's a real opportunity for using LLMs in and around code security.
Yeah. So as I was saying on the detection, which I think the other part of, I would say, the problem is, as you said, like you have more and more code that are being generated by AI. So it's when you think about it, is if you have an AI reviewing code generated by AI, it could create a bit of an infinite loop of, and you can conceptually see it's a bit of an issue, and you will always need.
I don't know how auditors are going to feel about
exactly.
that.
So you will always need a part of some deterministic good rules to secure your code. You can think about it as, in a language, as a grammar and stuff like that. You have a set of rules that you need to respect to write and to talk, and it's all a bit the same for code security. So I don't think this is going away, but definitely I think on the remediation, and it has been a big challenge we are solving at GitGuardian, and a big, for me, challenge in the security industry in general is like you have more and more vulnerabilities, and a lot of companies are really focused on, okay, I'm going to find every vulnerabilities for you. I'm going to find maybe, I don't know, secrets, SAST issues, vulnerabilities in dependency, cloud security issues. But at the end of the day, at a company, you have all of these problems. Like you just don't want to know all your issues and problems. You just want to know how, like, you can have a vendor, that can help you fix them, actually. So it's, when you think about it, for us on the secrets detection part, our mission is not really only detecting secrets and having a great secrets detection engine, is being able for our customers to help them remove all the secrets out of their code and all of the IT systems, so they don't get hacked. At the end of the day, it's really the mission of our company, and I think the mission of every security company is not only on detection, but really trying to fix the issues. And where GPT is great is when you think, especially for large enterprise, we'll find like 10,000 and sometimes 100,000 of secrets, and the remediation, especially in the, because we will scan all the history of the code, and you have companies that have, written code for 10, 20 years. So it's, billions of lines of code to analyze, thousands of applications. So the remediation, so we find a lot of issues, and, you want to be able to automate the remediation, mm-hmm. and to do that, like, you need really to have, to be able to have, to suggest, code fixing to developers. And really that's where, like, I think LLM will shine, and that's their big strength, because they have been trained on the whole open source code. So they understand every languages. So for them, it's easy to solve the issue of, like, okay, there is a secret or even a code security issues, like what's the correct way to do it, and just give some insights to the LLM, saying, okay, as a company, I'm using, I don't know, a CyberArk Vault. These are example of how to use the CyberArk Vault in different language. This is a piece of code where I have a secret. How do I use correctly, write the correct code to use a secrets manager to use a secret that not directly hard code it, put it in the code. So definitely use case like that. That's really where LLM shine, because you don't want, as a software company, to build a deterministic model of rules engine with multiple rules per language and per framework. And it's a lot of engineering time. Language are always changing, so you need a model that's able to deeply understand, the base of every language, and that is trained, that is really using all the code is seeing to understand all the syntax, and not trying to implement it yourself.
Mm-hmm. Mm-hmm. No, absolutely. Okay, well, I think that in terms of the I like the engineering approach you took to it, trying to understand the cost, trying to understand the performance, trying to understand the quality, You've got those benchmarks now. Obviously, that's something again that we can share. But overall, yeah, look, I think everyone is very interested in the implications of LLM for their work. Code security, secrets detection. This is a great use case. So thank you very much for joining us, Eric. If anyone has any questions, stick them in the chat. I'll share them back with GitGuardian. Obviously, that's a solution that you should look at. As you say, it's popular in its use on GitHub. Yeah, any questions, let us know. But don't forget, if you've got any comments, go ahead, share this with your friends, like, subscribe, all that good YouTube stuff. Thanks for joining us, Eric, and thanks all of you.
Thanks, James, for having me.